Okay, good afternoon. Am I audible? Yes. Okay, thank you. So I think it's my job also to welcome you and also to keep you awake for the next 15 minutes after a good heavy lunch. And thank you for inviting me here from the organizers. To introduce myself, I am Ram Mohan. I am from Bangalore. By profession, I am a software architect. And this astronomy related work and few other things which I do is one of my passions. This whole paper or the presentation that I am trying to do today is on a home-built radio telescope that we have built and put together. And I will just show the journey and what we are doing with it. And Anant is my son. So we built this together around 3 years back, three and a half years back, when he was studying his undergraduation in engineering. And so without much ado, I'll just start. This is the radio telescope which I put at my rooftop at my home. And I'll just get into the whole subject. So the idea of detecting meteors through radio medium has been there since the 1930s, and there are many people who have worked on it, and they were the first few pioneers who gave a relationship between radio meteors were one of the interferences which were there when they were doing radars and other things in their early days, and they use a VHF radio receiver at large distance. The whole concept is very simple. You have a receiving place, and then you have a transmitter, and then the distance between these two is a very large separation of around anywhere between 300 to around 1,500 kilometers, where it's out of the line of sight, and there is no direct reception possible between these two. And whenever there is a meteor which comes and interrupts the whole transmission, because of the meteor interrupting it, there is a bounce off of the signal from the transmitting station to the receiver whenever there is a meteor interruption happening. So this is the whole concept of the forward scatter, and this is what I'm trying to use as a concept to build the radio telescope. And we were trying to find out what are the means to have a 24/7 kind of radio astronomy being done. Most of the times it so happens people who are into visual or astrophotography or any of that sort, most of the times you'll have to find out whether it's a clear sky or the day is good and all that in order to do anything about the hobby. But what is that you can do sometimes 365 days? That was one of the questions that we are trying to answer. So radio telescopes do offer you that kind of a medium to keep working on astronomy 365 days. So there are two radio telescopes that I had tried to build earlier. So one is a 21 centimeter and 18 centimeter resolution radio telescope. This was built in 2018-2019, and I have a poster of that one being displayed there, and everything is home built and designed and built by us. And then we wanted to extend that 365 days. And one of the methods that we were seeing when we were trying to do some search over the internet was that there is a continuous wave signal which is most of the time sent out by the ham radio operators, and that is used as a meteor detection beacon. So in India there is not much such things available where there is a continuous wave signal which was available to us. And the second one is using commercial FM radio transmission, which we can use for the radio stations which are quite far away. That means that if you start listening to some radio station which is not transmitting in your city but some other city somewhere else from a different frequency, and this will act as a transmitter and receiver. In order for us to do that, you need to build a very high gain antenna, and then there needs to be a whole lot of circuitry next to it. And that is what we were looking as one of the ways that we can achieve this. And when I was searching, one of the papers that I found was from Sanjay Belapure from Pune Ferguson College.
Sanjay is his father,
Jaideep. Yeah. So there was a paper of him sometime in 2004. He had done this. So that gave some confidence that okay, this can be tried out. But from the 2004 till whatever we were trying to do in 2020, there was almost a lot of timeline difference as well. So there was a change in the way and the method that he had done. But we wanted to try with that base, and this is what we did. The whole design and build was kind of grounds up. We designed the antenna, and we used mostly 4MEC2 kind of antenna design software to design the whole thing and to do simulations of how when we design the antenna, what will be the throughput and the efficiency and all that. And then this whole thing was built using whatever available materials at home. So idea was to build what you can gather at home, and that is what we have tried to use. So a plumbing pipe, a plastic pipe is used. This is a plumbing pipe around almost around 1 inch diameter, and all these antenna elements are built from a copper tube. Generally you get copper tubes these days, which is also used for this AC and duct ventilation and all that. You get even the thinner ones which are hard. So there are soft and the hard ones. So I used a hard one and cut all the elements and built the whole elements using that, and the spacing and all that was designed using the antenna software. And in order to ensure that there is a ground separation and there should not be any interference from any other, so it has been hoisted on a 10 to 15 feet high bamboo pole. So that is the way this whole radio telescope has been built. And what we have used, here is a whole set of things. So this is a bamboo pole on which the radio telescope is hoisted. And then we have a wideband RF wideband LNA, and this is powered by 12 volt. And the way it has been done in my case is that it's hoisted at around 3rd floor. So where I sit and listen to signals, that is at around ground floor. So in order to ensure that the signal loss is minimized, so as soon as an output comes from the dipole itself, there is a backup of that signal with an amplifier. And then the way this is designed is that there needs to be a fallback. It means that we can listen to 2 different radio stations at the same point of time, which are very far away. So we were doing some simulations, which of those radio stations are not transmitting in Bangalore. They need to be 24/7 available, and they need to keep on transmitting. There should not be any interruption. So if there is an interruption of that signal shutting down in the night, we won't get meteors which are kind of active at that point of time. So we did some search, and there were 2 such radio stations which are available. One was in Sri Lanka, Ceylon, and second was in Madurai. So both of them are quite far from Bangalore. We did all the calculations and the curvature and all that to find out. And the way this whole thing is designed is that there is a fallback mechanism. Just in case one of them shuts down, there is another radio signal which is active from another station. So you have a fallback. And for every meteor which is detected, as of now, it can be stored in 3 different places. So there is one which is stored in the local laptop. There are 2 softwares, SDR console, and then there is a radio SkyPipe, which is a meteor. It's nothing but a straight charge program. And then there is a radio meteor detector. I'll come to this. So this is another program which I am, whatever the meteors which are getting detected are all kind of, it is then and there uploaded onto a worldwide database of RMOB. So Radio Meteor Detections Bulletin online. So I'm also submitting all these detections worldwide to also to the worldwide community. So this is how it's been done. And though it was built in 2022, we ran some trials till 2025 for every meteor shower to verify visually that they were able to see the meteor, and that was also being detected in the radio telescope. I am also part of ABA, Association of Bangalore Amateur Astronomers. The team was formed for Geminids meteor shower. Generally it is in December. It's quite clear this time, and they can also find out the meteor visually, they can see, and also they can check if it is also logged into the radio telescope system. So this way we waited for almost 2 sequences, and then we verified that it's all working, and it was found out that it was credible enough. Then what we did was, the way we find out whether it's a radio meteor or something else, it's a noise or actually a signal coming in, is that there will always be a baseline on the console, and there will be a blip on the baseline whenever there is a meteor detection happening. And the signature should be something like this, where as soon as the meteor enters the Earth's atmosphere, there should be an increase in the amplitude, and as it burns out, there should be a gradual decrease of the amplitude. So this is how we were, these are the outputs from the console, different softwares, and each one of them you can see we are verifying that way. So it was visually verified, then it was also verified with 3 different softwares to also find out that it was detecting meteors. Now in 2025, January onwards, this has been continuously uploading all the meteor data into rmok.org, and as of now we are the only ones from India who are uploading this data to RMOC and to the worldwide meteor community. I am also a member of IMOC. So this is the, there are around 60 to 70 people, including some observatories doing. So every hour this data gets uploaded, and you can check the data even now being uploaded at rmok.org under the name of RAM. Yeah, it's the whole characteristics, where it is located, everything is given there. And this is a 1-year data analysis of all the meteor showers that it has been detected in the last 1 year. This is month on month. This is day on day, and these are the list of meteor showers, which it is almost 16 meteor showers that it has detected. And this trend line of 1 year of every day's detection, when you map it to, when you map this to a meteor shower, this is how it looks, and this is from last 1 year. So with this, I come to the conclusion. So the conclusion is, though I want to extend this to direction finding and everything, it means that I need to add more antennas and do phase detection. As of now, this is a home rooftop, so I am limiting. If I do get space, I will design and probably extend this. So with that, thank you. And, if you have questions,
so thank you. We have a few minutes for questions. We can take 2 questions. Number 1.
Yeah. So have you faced ionization during the, because you have said 24/7, 365 days.
yeah.
So at some meteor showers there is a continuous, because of continuous meteor shower, there is ionization for a long time. Even
Yeah,
during daytime.
in fact, I can show you those. I have separate data for all that.
Okay.
Sometimes it comes in bursts, sometimes it is ionized, and there is a blip over and over. Even that is happening. I can show you that actually. I have not included that as part of it.
But you can separate each and
Yes,
every
you can separate.
meteor, because if there are continuous 3-4 meteors going on,
Yes.
then you will get a signal, a single signal. For
Correct. I can show you that. Actually, I have it in my laptop, not in the book. Yeah.
Okay.
Any other question? Yeah.
Generally, being a populated city, how does this work in your urban setting? Is it too much of a interference that you face, or you have to really keep?
Not really. Radio signals are that way quite okay. We are using, actually in radio astronomy, FM signals are considered as noise.
Yeah.
So I'm using the noise as one of the ways to find out the waves. Yeah.
So thank you very much.
Sorry.
Yeah. Last.
Just very brief. So have you compared your data with similar setup which they have put up a relatively noise-free environment, so to speak,
Yeah.
internationally, and then
Yeah, there is one data which is coming in from Japan as well.
yeah,
I tried to compare it with that. It's more or less this similar. There might be some differences because the way meteors might have been sighted there. So, but when you look at the ZHR counts of each one of the meteor counts of the, it matches more or less.
Nice one. Thank you.
Thank
Thank
you.
you, Mr. Ramamohan. So let's move to the next point. I'll give you a signal after 10 minutes. So around that time if you wind up, then we can.
Okay, am I
Let's
audible?
start. Yeah.
Okay, am I audible? Fine. Hi, this is Avidas Gupta, and I'm coming from Center for Cosmology and Science Popularization in SGT University. And over the past 2 years, we have been developing our science popularization program in using different things. So we will just have a look out on that. I will go with overview, and then we will discuss different themes on which we are working. So in general, we have divided this science popularization program into two major categories. One is we have a mobile planetarium, and we conduct mobile planetarium program. And the other thing which we have developed is science center and different interactive exhibits and hands-on workshops. So using, since this is a university, we have a major benefit of having a captive audience in the university and also having outreaches outside in rural or urban sectors. We carry out all these different types of events in these under this science popularization program. So I will just give a snapshot and then probably I will go and discuss more. So this is our. So this is our science center. I will show you a virtual visit probably a bit later. We have exhibits. We have planetarium dome, and we have this planetarium program. We also have hands-on workshops. These are some numbers. The reach. These are some reach which we had in 2024, 25, and 25, 26. But I will let the photographs speak. So we conducted different planetarium programs. We have this small astro van in which we can take this mobile planetarium to different institutions. So in beginning, what we used to do is we used to conduct these planetarium programs, and before this planetarium program, we used to conduct briefings. But later we realized it's not a useful use of time for the students. So what we introduced after the induction of science center models is parallelly we conduct outreach through demonstration and sometimes hands-on activities, and we conduct the planetary program parallelly. So there is a one set of students who are going through some hands-on activity and they are observing. And also during the planetarium program, what we have found out, the planetarium program is more run on like a show. We have reduced the times of those planetarium program, and we have increased the interactions with the students, because that's what we saw is more that's the feedback from the students. So we did this too, and it was actually a successful thing. Okay, so other thing we started was Astro Club, and one of our annual program in the university is Synergy. So these are the Astro Club students and other faculty members. So we made a team last year, and this is a general model rocket, but we thought of doing something different. So can we measure the height with respect to pressure differences or something like that, and then present these results. So this is something which the students started, and they created different models, and this is one sort of payload. We use simple Arduino and accelerometers, and thought of we incorporated this on the nose cone. So as you can see, the data is being read, and then we change the pressure. So what you see here is it's a normal model. That means that's a 1.25 water booster, and then launch it with this payload on top of it. And then we measured that what height it went. So this is the observed height, and then my dear colleague Dr. Mayu, he created one model. Dr. Mayu and Prajol both created a model which understood that if there is a water loss with water loss and without water loss, what is the height differences. So if we take the water loss because of increasing pressure, then actually it very nicely states what we have observed, right? So it's a small project done by students, and how simple hands-on activities can be stretched to a bit more, targeting a simple scientific problem. Okay. So this is one of the Astro Club activity which we conducted and presented. Next, one of our students actually participated in the AXOA program of ACE. He was interested and he applied and he went there. We also conduct hands-on workshops. So this is one Stellarium workshop which we conducted, and the bottom pieces are about simple STEM workshop for grassroots level kids, especially resource poor kids. So we conduct these. So these are all parallel programs which go on. We have public lectures. So this is Moon Colloquium by Steve Durst, and this is given by guests, and we also go for public lectures in different universities. Apart from this, we have this sort of experiments, again hands-on for some students. For some students it is demonstration. This is a tethered balloon experiment conducted by Dr. Sapnava and our team. Dr. Sapnava is there, yeah, so you can meet for more. So they came, and it was a very nice experiment for the students. Then we have other event days. So we conducted this planetarium program especially for this 100 years of planetarium, and also International Women Day in a special girls' school. Then we have participation in national education fairs. During we had a BRICS gravitation and astronomy conference in SGT University. So we ran parallel press releases and press news to take it to the people. So apart from that, we also have outreach outside NCR. So we conduct this through online sort of lectures or hands-on workshops. So this is one in Gujarat, 5 schools were trained, and this is with Bangladesh National Outreach Coordinator. This is in West Bengal. So we conducted this. Okay, so this is a virtual visit. This is the current Science Center condition. So as you can see, it is Research Center and Science Center incorporated together, and we carry out both the activities. Okay, so these are hands-on activities, hair station, these are telescopes, and other demonstration models. So we had certain learnings. So I think one of the next learning which I had is scientific temperament, exposure, and socio-economic frameworks. We need to understand that more, and especially it is not that socioeconomic privileges or in society would lead to scientific temperament in general. So we need to explore that part more. Then wrapping implementation of planetarium programs and contextual on the basis of contextual discussions. Converting hands-on workshop, which are small-scale hands-on workshop, to target simple scientific problems, and collaborating with different institutions actually increases the visibility of the program and also enthusiasm in students. So future directions we would like to work on is increase the hands-on workshop, initiate teacher trainings more in the NCR region especially, proposal for government funding, and enhance capacity and activities of astronaut. I acknowledge the project students which were working over the time with us, Anand, Kange, Lakshmi, Vesam, then synergy students were this. Then we had collaboration with different institutions and my colleagues, Dr. Mayur, Nilanjana, Devatam, and obviously, last but not least, our director, Professor Sami. So, thank you. Any questions?
Yes.
Yes. Yes.
You want a mic or?
Yeah.
First of all, thank you for this beautiful talk. I really love this initiative of taking this astronomy to various people.
Yes.
Regarding planetarium, like mobile planetarium,
Right.
I want to learn that what kind of content you show to kids, and how do you know that whether it's grade appropriate and it is learned by the students. So, like, how do you measure the learning outcomes of the student when you deploy a mobile planetarium? Or is it a licensed version or it's an open source? That's
So we generally use open source planetarium programs, and you can map the sort of NCRT, or because I'm doing in context of NCR context and especially state region. So you map those blocks, which is if they have moon phases or something like that, and you showcase those appropriate concepts, not going into much deeper concepts probably at that stage. So depending on which standards you are showing to, like if I am showing something like on cosmology, so I would rather show it to grades of 9 to 12 or something. So that's how you decide. Yes. Anything else?
Yeah, I had a question.
Yeah.
Thank you again for a great talk. You described so many things. As I know myself, you're interested in citizen science. So
Yes.
my question is are you involving citizen science projects, and especially at the college level, for getting kids interested in hands-on?
Yeah, so that's one of the things which Astro Club is doing. So because even in citizen science, on a very local space, you need a captive audience, right, of 5 or 10 people. So one of the aim of Astro Club is to implement that, to produce hands-on workshops, hands-on training first, and then probably implement then in citizen science. So that's how we are taking it forward.
Thank you.
Welcome.
Yeah, thank you. I think we'll go to the next talk.
Yes.
So, Mr. Jagaveshwaran will speak in Tamil and he will do translation. Thanks, guys.
name is Jagdishwaran, coming from Chennai. My organization, Tamil Nadu Astronomy and Science Society. So my language supporters Vajra Adeshinma. I am speaking Tamil, so translate the English. Hands-on activity. So சிம்பிளான மெட்டீரியலை வச்சு எப்படி வந்து குழந்தைங்களுக்கு பேசிக்கான ஒரு அஸ்ட்ரானமி சொல்லிக் கொடுக்கணுன்றதுக்கான ஒரு எக்ஸ்பெரிமெண்ட்டில் ரொம்ப முக்கியமான எக்ஸ்பெரிமெண்ட் இது வந்து ஒரு சாதாரண ஒரு பக்கெட் ஹேண்டில் ப்ளஸ் வந்து சைக்கிள் ஃபோக்ஸ் யூஸ் பண்ணி நான் வந்து ஒரு பேசிக்காக எப்படி சொல்லிக் கொடுக்க முடியும் அப்படின்னு நான் சொல்லியிருக்கேன். இதுக்கான மெட்டீரியல் ரெக்குவயர்மெண்ட் இதுதான். ஸோ ஹேண்டில், த்ரெட்டு, சிசர், பால்ஸ் இதெல்லாம். நெக்ஸ்ட் ஸோ இந்த மாதிரி ஓட்ஸ் போட்டு இந்த இதுக்குள்ளே ஃபோக்ஸ்குள்ளே போட்டுட்டிங்கன்னா இதை நம்ம வந்து பூமியாக எர்த்தாக பார்த்துக்கணும். இங்கே ஒரு ஆள் இருக்காரு. ஸோ இது வந்து சன்னு சொல்லிடுங்க.
Okay, I do that. So imagine that this is the sky, this is a part of the sun, and this is earth with the person. So with this simple device, you can explain sun's motion and things like that.
So
Day and night.
இதை பேஸ் பண்ணி ஆஃப்டர்நூன் அண்ட் ஈவினிங் அண்ட் மிட் நைட் மார்னிங் இதெல்லாமே எக்ஸ்பிளைன் பண்ண முடியும். இது வந்து ஒரு பேசிக்கான ஒரு டூல். Second one.
No, just I'll add one thing. So this is important because this is how we feel we stand on the earth. Usually we show earth like this, right? Like North Pole on the top. So even for children, I mean I'm just adding that. So we can get it.
So இதை சன்னுக்கு பதிலாக நீங்கள் வந்து மூணாக நீங்கள் கன்சிடர் பண்ணீங்கன்னா இதை வந்து எக்லிப்ஸாகவும் நம்ம யூஸ் பண்ணலாம். பசங்களுக்கு இதை வச்சு நிறைய எக்ஸ்பெரிமெண்ட் பண்ணலாம். ஸோ சோலார் எக்லிப்ஸ், லூனார் எக்லிப்ஸ் இதை வந்து எக்ஸ்பிளைன் பண்ணுறது ரொம்ப ஈஸியாக இருக்கும்.
So now you think this ball as a moon, not as a sun, and that torchlight as a sun. With this model, you can explain eclipses for only one other.
Next one. So கான்ஸ்டலேஷன் umbrella. ரொம்ப பசங்களுக்கு ரொம்ப இன்ட்ரெஸ்டிங்காக இருக்கும். இதை நான் என்ன பண்ணியிருக்கேன்னா ஃபுல்லாக இந்த மேப் யூஸ் பண்ணி ட்ராயிங் பண்ணியிருக்கேன். ட்ராயிங் பண்ணி அந்த கான்ஸ்டலேஷன் எல்லாமே வரைய வச்சு ஸோ என் பொண்ணு தான் என்னுடைய டாக்டர் தான் இதை பண்ணாங்க. இது ரொம்ப இன்ட்ரெஸ்டிங்காக இருக்கும். ஸோ நீங்கள் இது ஃபுல்லாக வந்து கான்ஸ்டலேஷன் ட்ராயிங் பண்ணியிருக்கோம். இதில் வந்து ஹோல்ஸ் போட்டிருக்கு. நீங்கள் தவிர்த்து அடிச்சோன்னா நீங்கள் பார்த்தீங்கன்னா தெரியும். லைட் ஆஃப் பண்ணும்.
If you can switch off this light for a second.
So ரொம்ப நல்லா இருக்கும் இது டார்க்கா கால்குலேஷன்
Ingenious.
I don't think I need to translate this. Yeah.
லைக் சார் லைக்
Can we copy your ideas?
கான்ஸ்டலேஷனை பேஸ் பண்ணி நம்ம பண்ணக்கூடியது தான். இது வந்து ஓரியன் கான்ஸ்டலேஷன். கான்ஸ்டலேஷனுக்கு ஒவ்வொரு ஸ்டாருக்கும் ஒரு டிஸ்டன்ஸ் இருக்கும், லைட் இயர்ஸ் இருக்கும். ஸோ உதாரணமாக 1050 லைட் இயர்ஸ், 240 லைட் இயர்ஸ், 800 லைட் இயர்ஸ், ஒவ்வொரு ஸ்டாருக்கும் ஒரு லைட் இயர்ஸ் இருக்குது. அதெல்லாம் வந்து இன்ச்சில் சென்டிமீட்டரில் கால்குலேட் பண்ணி ஸோ ஃபார் எக்ஸாம்பிள் light years are 6.4 inches.
So, for example, if you look at Ariane constellation, different stars are at different distance. So, he has made sticks which are proportional to the distance in light years. So, now if you attach, you can actually see how they are formed. Right?
So the மாதிரி one by one. Next. கைராஸ்கோப் வந்து எல்லாருமே தெரிஞ்சிருக்கும். கைராஸ்கோப் உடைய ஒரு மினியேச்சர் மாடல் சின்ன பசங்களுக்கு நம்ம இந்த மாதிரி ஒரு சிடி யூஸ் பண்ணி 4 சிடி சாதாரண பேட்டரி யூஸ் பண்ணி நம்ம சொல்லி கொடுத்தோம்னா ரொம்ப இன்ட்ரெஸ்டிங்காக இருக்கும். ஸோ அதோடைய ஒரு மினியேச்சர் மாடல் தான் இது.
So you use 4 series and a small motor and a battery. You can create a
ஸோ ஆஃப்டர் மோஷன் பிஃபோர் மோஷன் கீழே வந்துடும். நம்ம வந்து ஓகே இது ஜாயின் பண்ண பண்ணுங்க.
So once the motor starts rotating, you can see that it can stand horizontally. There is some, as usual, loose contact.
ரொட்டேட் பண்ணும்போது உங்களுக்கு தெரியும் அந்த டைராஸ்கோப் வந்து எப்படி ஃபங்க்ஷன் ஆகுது அப்படின்றத. இது வந்து ரொம்ப சிம்பிளாக ஒரு 4-5 CD வச்சு ஒரு சின்ன மோட்டர் வச்சு சொல்லி கொடுத்தோம்னா ரொம்ப இன்ட்ரெஸ்டிங்காக இருக்கும். அதுக்கான இது நிறைய மெத்தடில் பண்ணுவாங்க. நான் இந்த மெத்தடில் இது வந்து எக்லிப்ஸ் சம்மந்தப்பட்டது தான். ஸோ சன்னை விட எர்த்தை விட மூணு வந்து 4:1 சைஸு. ஸோ அதே மாதிரி டிஸ்டன்ஸ் பார்த்தோம்னா கிட்டத்தட்ட ஒரு உடனே செய்ய முடியாது. இதை பர்ச்சேஸ் பண்ணுவாங்க.
The F diameter is approximately 8,000 miles, which we know already. The moon's diameter is slightly more than 2,000 miles, which is about one of both of Earth's diameter. So how far the moon is that we are going to see. The moon is actually about 2,400 miles away from Earth. The moon is actually 3,048 kilometers away from the Earth. And that is Earth diameter. So this is our model. Each inch on that yardstick represent 1 inch diameter. Clamp the moon, toothpick to the yardstick 30 earth diameter away from the earth wall. And now you have a scale model of the earth moon system.
Okay. இது ஒரு டெக்னிக்கல் ப்ராப்ளம். ஸோ அதனால் இப்போ எக்ஸ்பிளைன் பண்ண முடியாது. ஸோ வெரி இன்ட்ரெஸ்டிங் ஒரு எக்ஸ்பெரிமெண்ட்டில் இது ஒரு டாய். ஒரு ஸ்கேல் 6 ஸ்கேல் உடன் ஸ்கேல் யூஸ் பண்ணி ஒரு சோலார் சிஸ்டம் வந்து குழந்தைங்களுக்கு எப்படி எக்ஸ்பெரிமெண்ட் பண்ண முடியும். அது வேறு சைஸில் வந்து நம்ம கட் பண்ணிக்கணும். கட் பண்ணிவிட்டு பாலை வச்சு ரொம்ப அழகாக வந்து குழந்தைங்க நம்ம வந்து செஞ்சு கொடுத்தோம்னா அவங்க வந்து ஒரு எக்ஸ்பெரிமெண்ட் நடக்கிற இடத்துல ஒரு எக்ஸிபிஷன் நடக்கிற இடத்துல அவங்க செஞ்சு வச்சுருப்பாங்க. வீட்டில் வந்து ஒரு மாடலாக வச்சுக்க மாட்டோம். இது ரொம்ப இன்ட்ரெஸ்டிங்காக இருக்கும்.
So basically cutting the scale and then making a design like this, you can kind of give a feel for a solar system, how parts are different and so on.
And it's a sun dial. It is made with a normal paper material. It is very loose. Okay, we can make it very easily, and we can take one printout, and we can create with kids low cost and low budget only. We not to spend more amount for this. Just take only one printout with the diagram. We can cut it and we can make this sun dial. It is easy to handle also. It is very useful to kids also.
Over 5 minutes left, so now we're going to come here, but now we will go for it.
Faces of moon with the vaccine or manning. Flip card using a flip card.
இந்த மாதிரி ஃப்ளிப்கார்ட் யூஸ் பண்ணி 2 விதமான சர்க்கிள் இருக்கும். இதை நம்ம வந்து கட் பண்ணிவிட்டு இதை நம்ம இந்த ஃபேஸஸ் ஆஃப் மூனில் வந்து வச்சுட்டோம்னா சின்ன பசங்க கிட்ட கொடுத்து இன்றைக்கி வந்து சன் வந்து நிலா வந்து எந்த சைஸில் தெரியுது அப்படின்றத நம்ம இந்த டிவைஸ் வச்சு இந்த 2.5 டேஸில் இருக்குது 5 டேஸில் இருக்குது அவங்கள வச்சு ஒரு மெஷர்மெண்ட் பண்ண முடியும். இதுக்கு வந்து நெட்டில் நிறைய கார்ட்ஸ் இருக்குது. இது சம்மந்தமாக ஒரு புத்தகம் இருக்குது. இந்த புத்தகத்துடைய
and astronomy related, which is in Tamil.
ஸோ சார் தான் அதுக்கான அனுப்பி எழுதுனாரு.
No, it's okay. So this is a book that he has compiled out of these kinds of activities for doing it in classroom. It's in Tamil and it was created for a particular purpose. In Tamil Nadu there are what has been called as model schools. The Tamil Nadu government has created some 40 model schools. Now it has been increased to about 250 model schools, right? So in these schools, children who pass out of 8th, if you perform well, then the government makes you offer. So the government will give you free boarding, lodging and education, but it's a compulsory residential school. So in these schools, in addition to your textbook, there are many other expositions. One of them is astronomy. So there is a regular 3-hour astronomy program every week for this school children, and which is conducted by the Tamil Nadu Astronomy and Space Science Society. Okay, Astronomy and Science Society. Okay, society. And this book was supposed to be a handbook for that experts who go to the school.
இவ்வளோ அந்த கார்டும் கொடுக்கணும்.
It has nearly 25.
There are also cards attached with this, which with you can make the material from this book.
Thank you.
So we have some 2-3 minutes.
Where can we get this?
Yeah.
Where can you get the book?
That's okay.
Read the context. Read the context.
So you want to buy where?
Yeah,
This is my contact number. Please send your number,
Will you
details and that.
upload this to the drive which Neeraj sir has sent?
Yeah, this PowerPoint will be uploaded to the
Okay, still
Yeah, it will be updated.
Right.
And we want to take it.
Or during the tea break, he says that he will leave it on the table. You are most welcome to come and explore yourself.
Just take a look at the people.
Any other questions, comments? Get my yeah.
நம்பர்லால நாங்களே பண்ண முடியுமா?
நீங்க பண்ற மாதிரி தான் நான் பண்ணிட்டேன்.
With the help of solving Elena.
புக்ல வந்து full details இருக்கும். நம்ம 3 days இங்க இருப்போம்.
So what the question is that can we really do it with umbrella by ourselves? He says yes, you can do it, and he is there for 3 days. If you contact him, he can even teach you if you buy. Come with the, if you come with the umbrella. Umbrella and permanent marker, you come to him, he will teach you.
Night.
So he says one day night workshop. Yeah, so good, no?
Nowadays, distances might be to the scale, but the sizes of the patterns are not to the scale.
We can make that. Even distances are not to the scale. They just want to give an idea. You can make if you want. It will be really good. Okay, so we have had a very wonderful session, 3 talks, 3 different facets. One with radio astronomy, which we thought is not part of, let's say, popularized astronomy, where it can be done only by researchers, not by amateurs. But here you can see that amateurs can do very interesting work, and then let's say if you are an engineering college or even a science college, such kind of activities will actually enrich college education. So that's one talk that we saw. And in the second, we saw how an educational institution, if there is a systematic effort and some systematic thought, we can make new ways of communicating. For example, you saw the whole computer lab being converted into a stellarium lab, right? So, for example, with the stellarium, you can do some projects, like say, for example, finding the distance between Earth and Mars when there is a retrograde motion and things of that kind. You can create some computational projects. So, a lot of very interesting work one can do even with stellarium kind of software. And the last one is, of course, hands-on, low cost, very captivating. Yeah. Thanks to all the 3 speakers and the participants. I think we have earned our tea, right? Have we earned our tree?